what I'm going to do now is for Arlan Andrews, I'm going to read his, he sent us the script of what goes with his presentation since he wasn't able to come himself. He says, "Good morning, I'm Arlan Andrews." I'm not, but my hair grew a little bit. I'm speaking to you today as the founder and director of Sigma, which is a science fiction think tank. And I'd like to take a moment to say what Sigma does. It's a group of scientists, military people, government, people who've worked in the government. The basic idea is we're also science fiction writers. And we consult for originally the Department of Homeland Security, and then it expanded to include other agencies with lots of initials too. And eventually to industry too. The idea is that we're futurists. You know, we project futures for the military, for the government, for analysts within the government about where we think we're going in the next 10, 20, 30 years, for example. It's very useful to have a group of people who aren't in anyone's chain of command, right? We don't have to worry about what our employers will think if we suggest an idea that sounds out there. If thinking out of the box is what we do for a living. So that's why they like to bring us in so we can brainstorm, and we're not afraid of looking bad or of being considered, you know, out there by the people that we work for. Arlan Andrews, whose presentation I'm about to read, was the founder of Sigma, and that's he put like 4 words in there. I put the rest of that. Other Sigma members here today are Dr. Catherine Asaro and Alan Steele. This is what we do, offer futuristic thinking. We've done it dozens of times for federal agencies and others. We welcome your inquiries. When I was first asked to give this talk, I was going to approach it from a purely technical standpoint. How do we achieve the detailed objectives from a designer's perspective for repurposing androids? Repurposing asteroids. But as I reviewed the earlier presentations to be given by true experts in the field, I realized that these scientists and engineers would also be covering the facts. So that left me fiction, science fiction. So I decided to approach the challenge as a writer, not as an engineer or an expert on asteroids. Although, to be honest, Arlan has a lot of areas of expertise. He's being modest here. From the catchier technical title of CARPE DIEM, I settled on repurposing asteroids, with subtopics all relating to the science fictional aspects of the subject. The first slide is from the more dynamic Prezi presentation I first expected to give, but I've now translated it to a standard static PowerPoint. I won't get it to jump around and zoom in as originally planned, but Catherine will read it for me. Okay, science fiction gives us a way to think about real and imagined problems in any field ahead of time to prepare us for various possibilities. And our imagination is a lot cheaper than engineering. The bullet points here are self-evident. Everything to do with space travel was actually first envisioned and discussed in science fiction. And asteroid repurposing is no different in that respect. Looking at asteroid exploitation from an early science fiction writer's perspective gives rise to an entirely new way of evaluating asteroid potential benefits. And finally, science fictional thinking can come up with ideas far beyond the balance sheet. Asteroids are a vast backdrop upon which science fiction writers have projected their stories over the past 120 years. And he gives a number of covers there from some of the more well-known ideas from various people like Robert Heinlein and Jerry Pournelle. The ideas and visions are worth discussing as the new age of asteroids is rapidly approaching. In 1898, novelist Garrett Serviss, I hope I pronounced that right, had intrepid Earthlings going out to attack Mars to avenge the earlier attacks related in H.G. Wells' War of the Worlds. En route, they encounter a solid gold asteroid already being mined by the Martians. After a battle, some of the Earthmen humorously throw gold nuggets back toward home, taking advantage of the low gravity. This may be the first written account of asteroid mining. The story that inspired my talk today was this one from 1939, where author Robert Heinlein has workers in the Cosmic Construction Corps relocating asteroids between Earth and Mars to serve as way stations, an idea which came up in part, I think, earlier in a talk here this session. In the case of Heinlein's story, they hollowed them out as human habitations. The late Dr. Jerry Pournelle, also a Sigma member, wrote science fiction and also served as a science editor for the science fiction magazine Galaxy. In 1979, he summarized his thoughts on exploiting asteroids as a near infinite resource of materials for Earth. He analyzed potential propulsion technologies, energy requirements, methods of capture and retrieval, and the possible net benefits. When I considered Pournelle's contributions to asteroid exploitation, I was inspired to come up with a practical shorthand means of visualizing his conclusions. Based on the thinking of Jerry Pournelle, on the broad overview of how he approached the potential benefits of asteroid mining, I came up with the following metric, a new unit that I would like to propose here for the first time. Pournelle's vision, as summarized, one neutral measure of the wealth of a nation is its per capita usage of industrial metals. By all measures, at least in the 1970s, the United States was the world's leading economy, its wealthiest and most productive. Our usage of industrial metals is proportional in some sense to that wealth. Pournelle calculated that just one asteroid could conceivably provide that same amount of metal to the human race, and there are thousands of them out there. I decided to take Pournelle's vision one step further. What is the amount of industrial metal mined in the whole world? What if we could multiply that many times using asteroid mining? How would we keep track of all that wealth? Business Insider magazine in 2014 published a list of important commodity metals: platinum, gold, silver, uranium, nickel, copper, and iron, and the volumes of each that were mined in the year 2013 globally. The question arises, what size of an asteroid would we have to exploit to get access to those amounts of the metals? Calculating the earthly volumes, assuming we can locate an asteroid with basically the same constituent metals as Earth, and using a 0.3% yield from its ores, the answer is, and then he wrote, just one single asteroid 4 miles in diameter could double Earth's yearly supply of all those industrial metals. And as Pournelle says in his articles, there are tens of thousands of asteroids of that size out there. To give a standard way of estimating the value or the worth of an asteroid's mining potential, Arlan proposed a new unit, and he's naming it. He and Jerry Pournelle founded Sigma together, so he's naming it in honor of Jerry. The Pournelle volume, abbreviated as PV, where 1.0 PV equals the total global production of a given earthly commodity in a base reference year. For example, using 2013 as the reference year, 1.0 PV of gold equals the total Earth production of gold in 2013. That is 154 cubic meters. 1.0 PV of iron would be the total Earth production of iron in 2013. That is 375 million cubic meters. Using these photos from Business Insider in 2014, we can easily visualize what 1.0 PV of a given commodity is. The volumes of each metal here are easily comprehensible, and it is not difficult to envision asteroids of comparable size providing the same amount of metals. The PV unit makes meaningful the comparison of future investments in capture, processing, and retrieval. Think of a board meeting of an asteroid mining company 50 years from now, in 2068. We think asteroid X285 will yield 0.5 PV of platinum, 0.25 PV of gold, 1.5 PV of silver, and 0.1 PV of iron. Do we proceed or do we look elsewhere? Notice there is no mention of monetary value here. That kind of value will naturally arise from the commercial, industrial, and decorative utility of the metal. So the PV unit is independent of the market values of the commodities, because as the first few PVs of precious metals arrive back on Earth, the market values based on their scarcity could collapse. Precious metals will no longer be even a hypothetical basis of monetary value. When you cast your toilets and bathtubs out of gold and silver, such metals will lose their traditional, indeed almost legendary value. So some kind of cryptocurrency will have replaced precious metal-backed currencies, probably long before those first PVs come down from the sky. Now is the time to begin preparing for that disruption in the international financial community. On the other hand, if tradition does persist and we need a physical representation of wealth, maybe we could agree to set aside a large asteroid, Pallas, Vesta, or whatever, as a hypothetical repository of all earthly wealth, and use its very presence as the basis of a new currency. Given the hundreds of science fiction stories taking place in and among the asteroids, including the excellent TV series, the rather gritty and realistic The Expanse, it may be difficult to come up with ideas that haven't already been expressed, but again, we can speculate for free. Some of these following suggestions and scenarios might be impossible or funny, or just fun. But given the record of science fiction in projecting potential futures, they should be considered as possibilities, if not probabilities. The equipment and techniques for asteroid mining will be applicable to tunneling or hollowing out suitable asteroids for human habitation. Those that contain ice will have the necessary constituents for an atmosphere. The potential uses of asteroid bases and as ships are countless. People may need gravity in their asteroid habitats. Spinning tethered asteroids may be more feasible than rotating a single asteroid habitation on its axis, especially given that not many such rocks will be symmetrical. I think it was John, you had the videos of the spinning asteroids. I don't think any of those were close to symmetrical. No. Advances in graphene and other materials in the next decades could provide tensile strength for such tethers. Embedding future quantum computer systems in the tethers will provide the continual adjustments that provide stability. Okay, what he writes for this slide is self-explanatory. Yeah, he does say smart tethers may have many uses, clearly. There are many uses for these various configurations. This one is a collection point where asteroids are brought in tethered and then mined and or modified by the station crew. This one he also says self-explanatory, new moons for Mars and Venus. Myriads of possibilities when asteroid repurposing and relocation are commonplace. And he lists some of them here. So the first one is scientific observation stations, orbital factories, which I've always found intriguing, transfer stations between deep space and atmospheric craft, potential commercial applications, receiver stations for incoming asteroid materials, and finally, one of the most fun aspects was sightseeing and tourism, which we're already getting a little bit into that now with some very rich people finding ways to go into space. Being very careful around Earth, a fleet of properly positioned asteroids could provide a defense against rogue bodies coming toward Earth. And he says all the other applications work here too, so just to mention these. So an array of small asteroids orbitally positioned and propulsion prepared for interception of approaching comets or asteroid, a last-ditch defense system. In other words, how do you stop an asteroid from hitting the Earth? Could you use these? Did somebody say a credit card? Yeah. Actually, my dad was the nuclear chemist who found the iridium anomalies that Alvarez, Asaro, and Michael used for their theory to propose that an asteroid hit the Earth and killed off a lot of things. So I have a special fondness for ways of finding how to stop asteroids. Hollywood does too, but I think Arlan's ideas are probably more feasible than most of the Hollywood ones. What?
A good guy with a bigger asteroid.
Yeah, that's right. Anyway, he lists quite a few ideas there. He says, speculation, again, is cheap. So what else can we do with repurposed asteroids once the techniques and equipment are common engineering practice? Probably no more complex than designing, building, and installing today's deep ocean oil drilling platforms. And then he goes on to say, by comparison with previous technological developments, it is conceivable that supportive infrastructure and related commercial and military opportunities will arise as the age of asteroid matures. And we can, to propose the ideas costs nothing. Of course, then we have to get the money to actually do them. We're probably closer in terms of feasibility, though, to mining the asteroid belts or otherwise using asteroids than we are to some of the more far-ranging interstellar ideas that you've heard today in this section. Potential placements of repurposed asteroids. He says there's a lot of possibilities. Place new planetoids, maybe robotically staffed, very near the sun to study it. Out-of-place elliptical orbital placements may provide optimal transfers as space industries develop. And then he gives these three possibilities. Launch instrumented asteroids perpendicular to the ecliptic to study phenomena in that new environment. Most of the time when we talk about the solar system, we're talking about doing things in the plane in which most of the planets orbit. They all orbit in the plane, though it's not completely flat. So this could provide us a way to study the solar system in a way that we haven't seen before. Propel smaller instrumented asteroids out to the Kuiper belt. How do you pronounce that word? Kuiper, that's it. To the Kuiper belt to study objects out there. And finally, launch fleets of small instrumented, I don't know how you pronounce that. Anybody? Instrumented asteroids out toward nearby stars. So there's a lot we could do with asteroids that we talk about doing with satellites, but we might have more versatility using asteroids. An asteroid-based society could provide the basis for an interstellar colony fleet. And if it's raining soup out there, We need to figure out how to make soup bowls. And that is the presentation put together by Arlan Andrews on asteroid repurposing. Thank you.